Up, Derek, 13 Series Engineering, and today we are going to be going over a video that somebody requested, or a topic rather, that was requested in the comments, and that is how to do polymorphic relationships in Laravel with Eloquent, how to do that in Doctrine. Because Doctrine doesn't really support this out of the box, except they do totally support it, they just don't have an easy way to do it. So we have to kind of do a little custom implementation of in our repository to make this happen. Polymorphic relationships are kind of confusing if you're newer to entity relationships and things like that. They've definitely been really confusing for me up until recently, but they're actually really simple when it comes down to implementing them. And so we're going to do 3 videos real quick. We're just going to talk about some things and look at a diagram right now, and then we're going to implement one-to-many, and then we're going to implement many-to-many using our star planet system, solar system planets API that we've been working on. It's a great time to look at relationships and look at some of the flexibility that you have, hopefully without sacrificing too much performance. And just to give some context, the whole idea of this is that you know, using a polymorphic relationship will achieve the same goal as like a regular pivot table, or adding lots of extra foreign keys to an entity that will slow down your database. And it basically um, it helps you limit writing joins instead of very complex data structures, and you do a lot of the work in code instead of in the database. So that's kind of the idea. So we have flexibility, and we have this concept of, in Eloquent, polymorphism is you have a child entity, and the example they give here for one-to-one is images. That's our child, and that child actually has 2 parents, and it doesn't have 2 explicit parents. What it has is 2 parent types. So it could either have users as a parent or posts as a parent. We don't know which one, but what we are going to do is we have this imageable ID, which is either the user ID or the post ID, and we have imageable type, which is either users or posts. And it shows you in someplace. Okay, so if we look at, this is why we're not doing one-to-one. It's very simple, and it's kind of backwards of how we're relating stuff. But what this query, if we get the image from the user, this query, even though we're giving it imageable, and you'll see in a sec here when we go to the next one, what's really happening is it knows it's coming from the user, and type is on images. So the type for that is going to be users. That type's important because it tells us where to query to get the parent entity, and it also tells us where to hydrate. You know, what mapper do we use to hydrate that object? So it's pretty straightforward. Again, we're not going to do one-to-one, but we are going to do is one-to-many. So if we look at this, really, what's the difference between these two? We have the same exact table structure. Well, I don't know this for sure, but I'm willing to bet that the one-to-one relationship is there's a unique constraint added, that the idea here is that an image or a user has one image, or a post has one image, and you wouldn't have to add a unique constraint, but you'd probably want to. And what makes this one-to-one is the way it's being queried. A user is getting their image, or a post is getting their image, and that's basically that's how that's working. The user has one image, a post has one image, and they're just getting their image that way. And you know, personally, I don't find a ton of usefulness in this example, because you could just have image ID on either of these and then grab the image that way. So you could just do it backwards and it would work. Um, and if you wanted to have images related up the other way, then yes, it would be an advantage, because you'd have user ID and post ID. And they would have to be either or, and one would have to be null. So we're avoiding doing that, but also you could just have image ID on user and image ID on post. You know, and you could get into some trouble with constraints where it's like the image wants to be related to one thing. So you have to make sure, you have to enforce that has either a user ID or a post ID related to it, blah, 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 all that. So I totally get where there is some usefulness in it. I would probably do it a different way though, if it was up to me. But one-to-many, this is where we actually get into the usefulness of this. A video or a post can have multiple comments. So videos have lots of comments, thousands of them, and same with posts. And we're doing the same thing here, is that the commentable type is either videos or posts. The commentable ID is either a video ID or a post ID. And this is what we need to set up in our database, essentially. Um, and the model structure, if you look at blah, 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 it's still querying it through the same way, but we're going to have a little bit of an advantage if we want to do something a little tricky and go through things the reverse way. And that's one of many is basically, if we wanted to, we could reverse query um, the comments from the video by telling it what class to look at. And that's something I think we'll get into as well. But just to look at our, our table structure, we're going to add a new entity and well, two new entities and two new videos. But the first one we're going to add is I want to do something with like satellites, because every body, a planet or a star or solar system, they all have satellites, meaning something orbiting them. What types of things can they have orbiting them? Well, we're going to do like a spacecraft. I think that's a good one. Um, we'll give it a speed, and it's not going to, oh, I haven't used this probably since college to have these, we can, we need to remove rows from this, delete row, there we go. Okay, so we'll just do name and speed for now, that's fine. Maybe I'll think of something cooler to put in there. But let's see, our spacecraft is gonna be related to planet or star. And how are we going to do that? Well, I just lost it. Where do I get my, there we go, insert below. We're going to have, oh man, and this is, the language of this is like, oh, here's the cool thing about not using Eloquent is this would be spacecraftable. And like, that's, uh, I don't want to do that. So, um, orbitable. I think, there we go. It has orbitable. Um, orbitable ID. Oh, and my I key is not working. This keyboard's starting to go out, I think. Um, where are we? Insert below, and then orbital sounds cool. I like that. Orbitable type. And, you know, we're doing this on PHP. This is going to be a varchar in the database. And okay, so these diagrams, just so everybody knows, these are like the entity diagram, not the database table. These are like the fields in PHP, which is like, name, lumen, string, UUID. Obviously, in the database, that's there's something different, but just worrying about that for the time being. So spacecraft can either be orbiting a star. If you think about like um, this isn't right. What do we need to, uh, I haven't done one of these in forever. I really can't remember. Shouldn't it be two pluses and not a crow's feet? I guarantee this is wrong because it's like this right here, this little thing is 1-to-1. That's basically what we've got. Maybe I can change it if I click on it. Oh. I don't know. Oh, it's up here. There we go. Sweet. I think it's supposed to be like that. Uh, But either way, the orbital ID is going to relate to either a planet or a star ID. So, some things orbit stars, like the Parker Solar Probe is orbiting our sun, pretty sure. And so, you can have things orbiting um, orbiting a star or orbiting a planet. The ISS that orbits our planet, same with any of the Starlink CubeSats. So there you go. In this type, basically, um, I might have to look this up, but the best thing, we might just leave it as a string because it's easiest. But in Postgres, we probably would want to have some type of enum for this, like, you know, just so we don't break anything, planet or star. And that's all you can pass it. And then in PHP, all we have to do is a backed enum, um, which would be super, super easy. So I don't know if Eloquent does an enum like that or not, based on the migration, but um, it might not. But that's the right thing to do. And we have some awesome flexibility to be able to, that looks so wrong. We have some great flexibility to be able to do that stuff, because we're doing our own implementation. And the good thing is, what's going to make this awesome is that Doctrine, using DQual is going to query on the actual class name and then hydrate it for us. So we need to pass the actual class name. So probably this isn't going to be like planet. It's going to be like app, uh, entities, planets. Oh, they're all escaped. Um, planet, blah, blah, whatever. That's like probably what the enum is going to look like, is the actual class, not just the word, um, star or whatnot, because we're going to use DQual for this. And the cool thing that we can do, creating an enum or just passing the class, that's the debate. Should we create the enum in PHP or just create it in the database and then we just pass, like the planet class? When we actually build this using DQual, it's going to be pretty slick, because we're just going to essentially query X from whatever class it is, by the ID, and it's just automatically going to hydrate it. And it is kind of shocking that Doctrine ORM doesn't support this, because it very easily could. And I think we're going to see that as we build it, is that it's not going to be super complicated. There's not going to be joins and a bunch of crazy stuff like that. So that should be a pretty simple implementation and that's what we'll go through next. Um, Now the next thing we're going to look at is our many-to-many relationships and polymorphic relationships, and this is where we get a lot of power. With many-to-many relationships, you are going to have a join, you're going to have a pivot table, um, but you're going to be able to, you know, how does that relate to our orbit example? Well, in this example, you know, the same video and the same post, well, a video and a post that are different things, they can have the same tags, or they can have like the same exact set of tags. That's essentially what this taggables pivot table is letting us do. We have a single tag ID here that it's related to. That's one tag, and that tag is then related to a video ID or a post ID, and it's given the type video or post. But we can have the row below it, same exact tag ID, but its taggable ID will be the opposite one. So, let's say you had a row, tag ID 123, and its taggable ID is post 234, and the taggable type is post. We can have the same 123 tag ID right below it, and its taggable ID is going to be for a video ID 5678 or whatever with the type video. So that way the same tag is now related to you know, multiple entities at the same time. It's not just only like, well, you can have a planet or a star. You can be related to one spacecraft can be related to planets or stars. Um, and I was going to call this satellites, but I like that we have orbitables. Um, and you can actually, you can get even crazier than this. And I think they might talk about that in their docs on the dynamic relationships. But you can have one like insane pivot table where you can basically, I don't really want to go through the rabbit hole of doing it. Where's their table thing? Well, you can uh, basically make the other half of the relationship something else, like a question mark, you know? Like it could be tags or it could be comments too. Um, and I don't really know exactly the use case for that is, but you can get insane using like these type and ID pairs if you want to. We're not going to get into all that, um, but we are going to kind of recreate the same thing. So we have our orbitables, and we're going to have our um, well, I guess we kind of could. It would be fun. It would be more practical. The thing is with our use case is like one orbit thing is not like it's not going to be orbiting multiple. Um, it's not going to orbit a planet and a star at the same time. So, hmm, that's kind of our use case we need to figure out because a tag can be tagged to a video and a post at the same exact time. I mean, technically, the spacecraft is orbiting Earth and the Earth is orbiting the sun, so like indirectly, it's orbiting it. It's orbiting the solar system. But, hmm, what would be a good... Wow, that just jacked everything up. Orbital ID. Well, we're gonna do orbiter ID, orbital ID, and orbital type. Um, so that's our pivot table. And the orbit instance works for like one to many, but what about many to many? Hmm. What do planets and stars have in common? That we can do something with. Not just the orbiting thing. It's got to be something else that they would both share multiple of, or only one could have, or only the other could have. Um, I have to think about this. Well, we're gonna get back to this. Okay, I think I got it. This is what I came up with. I don't know if this is the best example, but it is a uh, example. We can still use orbitables, but it's gonna have a different meaning. Maybe that'll just be uh, we're gonna make a table called astrodynamics, and that's gonna go to a uh, body ID and then a pathable ID and a pathable, or, that's gonna go to a pathable ID and then a body ID and a body type. And I know that obviously the naming convention here is a little divergent from what Eloquent is doing, but we're going to have astrodynamics. If you don't know, if you ever seen the movie The Martian, they kind of talk about it, but it's basically like orbital paths and dealing with like gravitational pulls and stuff like that. And it's like, how do they figure out how much a spacecraft needs to slow down so it doesn't slam into Mars and orbits it and gets caught by its orbit? Or how did they figure out to send Artemis 1 how did they figure out to send Artemis 1 like this, like way far away from the moon? How did they figure out how to do that and get it to come back? They didn't, they might have done like a slight fuel burn for this, but like to escape the moon's gravity a little and then have it slingshot back around. But like, how do they do that so the orbit's not a perfect circle? And it does, oh, here we go. Perfect. Oh, I wonder if one of these for Artemis. There's one, there's two. Oh, that's so cool. This stuff is, look at that. That is just, that's nuts, man. This is astrodynamics. So, and this is a great diagram for what we're doing because we have these different colors, okay? And these different colors are um, orbital paths. And there's probably an actual science name for that. I don't know what it is, but that's what we're going to have. We're going to have orbital paths, and we're going to have an ID, and sure, we'll give it a path name, and um, we can delete these. Oh, that was wrong. And okay, a speed. Well, I guess that kind of depends on your. Maybe we'll it's like speed times mass and a bunch of stuff. Well, I'm not going to get into all that. Well, we'll do like a shape. Maybe it's because we might, um, every orbit's basically an ellipse. Um, so major axis, minor axis, is that the only things you, how do you measure an ellipse, you know? We don't care about the area, we're just caring about, I like that. Even Earth's orbit around the sun is elliptical, it's just very minor. So major axis, sure, yeah, decimal. Minor axis, and so going to be length. So that's like our orbital path, and then there's a ton of stuff we could add to this, like maximum speed times mass. Like if depending how what your mass is, what's the fastest you can be going and actually achieve this, what's the slowest you could be going and actually achieve it. So there's a ton of stuff we could add. We're not going to do that though. But yeah, the ID, just like tags, goes to the pathable ID, and then a body could go to a planet. It could go to a star. It could even go to a system, which is just like, what do we even have in system? Uh, oh, we have, we just have system and name. Yeah, that's it. And then the planet, because the planets are, right. Okay, I remember. Why does it keep doing that? I cannot, really? Delete row. Oh, I think I'm just clicking delete, not delete row. That's why. I read can't good. Okay. So there we go. Our astrodynamics pivot table will go to an orbital path um, that all these things, um, it's describing their orbital path because a planet orbits a star typically orbits something like a galaxy. I guess that's the same as a system orbiting a galaxy, but um, they maybe would have the same orbital path. But we could also have our spacecraft that's going to have the same thing. Like everything is going to. Um, can I show recently deleted on here? I bet you can, I just don't know how to. What do we have there? We had like speed or something. Um, but oh, come on. There we go. Really? Wow. This is crazy. I just can't click on anything. But a spacecraft is obviously going to have, maybe that's a better example than system, or maybe that's maybe the whole entire solar system orbits around a galaxy. So maybe star, but stars can orbit around each other in a path. I don't know. I say we leave it. Everything basically can somehow have an orbital path, and it can have, maybe even multiple orbital paths. Um, and here's the cool thing about a pivot table that gives us extra flexibility is we can mark the entry with something. We could be like uh, status. So it's like for a spacecraft, um, it might have a bunch of different orbital paths it's given around different things, but it's only doing one right now. It's only orbiting the Earth right now, and then it's going to switch to its moon orbital path that it has or whatever. And same thing with like a planet where something might change, or we're tracking like, well, this planet was ejected from this solar system and it had this orbital path and now it has a different one. And so that kind of gives us like the ability to have, of course, the saying whether something's active or disabled, a spacecraft isn't going to have multiple orbital paths at literally the exact same time, but it could still be related, um, you know, to multiple paths. And these paths that we have, we're obviously going to get into a point of having like, even though they're very specific, um, but we're going to get into a point where they have duplication. And maybe the orbital path that a spacecraft is going to take around the Earth is also going to take the same orbital path around Mars because they're similar in size or something like that. And of course, Mars has a different mass than Earth. And even if your mass was different by like, you know, um, a few million tons or something, you would need to adjust all those things. But for the sake of doing this, we're not trying to do astrophysics. We're just looking at an example. This could be ice cream or a McDonald's order or whatever it is you want. But for us, we're doing planets. That's kind of the idea. Is that what this is going to look like is, let's say we have like an orbital path and it's like 50 by 25 whatever arcsecs or however you're going to want to maybe um, you know in tens of millions of kilometers it's going to be like 50 by 25. Well, you probably should have like units or something to that. I don't know, but you know spacecrafts can have that, and maybe it's a small planet or a moon or something else is going to have that. Anyways, you get the point. We have all this flexibility, we have all this stuff we can do to relate things without any type of the orbital paths. It doesn't have any key to like a planet or a spacecraft, and the spacecraft doesn't have a key to an orbital path. And it's the same thing with the one-to-many spacecrafts example that we kind of just showed, is that a spacecraft is related to um, or a planet might have many spacecrafts, a star might have many spacecrafts, and we don't know what they are until we query it, and it just gives you a lot of flexibility. Just like in their comments, you know, um, the comment goes to a video or a post, our spacecraft goes to a planet or a star, and each planet or star can have multiple of them. Um, I think it's good to also think about, why would you be doing this? Um, well, um, each comment in this specific example, just like with us, each comment or each spacecraft would need explicitly a video ID and a post ID and whatever else you're relating it to. This example is just two. So it's like, okay, that's not a big deal. But what happens when you get to like 10 different things? that's when it's really like, okay, we have 10 columns now, 10 ID foreign key columns. That is a lot to maintain. And this example isn't very practical because it's so isolated and small. But in a bigger example, like what we're starting to get into here, is that we have all these things that can have spacecrafts. Well, I guess a spacecraft could have another one orbiting it, like a big old space station or something. But um, you start to get into having like tons of just ID columns all over the place, and um, the polymorphic relationship prevents that. It just makes it so, hey, spacecraft can go to all these different things, and all these different things can have multiple spacecrafts or whatever. So that's what we're going to implement um, next time. Is I'm going to just screenshot this so we can remember to build everything correctly. And we're going to go way back here and look at the original one and probably screenshot that too. Cool. Just so we can remember next time what we're doing. But yeah, a spacecraft is going to a planet or a star, have multiple of either ones, and we'll build that out in just a minute here.